So the only other piece here that we're going to talk about is combining like terms. So in order to combine like terms, you have to be able to identify what is the variable, what is the coefficient, and you have to make sure that your variable, if it's a like term, has the same exponent, okay? So when we combine like terms, we are looking for the same variable and the same exponent. So make that nice and big in your notes. It's written down below, but I'm going to make it nice and big here. Same variable raised to the same exponent. Okay, and this combining like terms helps us simplify our expressions so that they are eventually easier to solve when they're part of an equation. So same variable raised to the same exponent, that's what we're looking for when we want to combine like terms. Okay, and your learning target for this part is I can combine like terms. All right, so what we're going to focus on for a second is identifying those coefficients, variables, and the exponent now. And then we're going to look at how we combine like terms pretty briefly. So let's look at this, take a look at this chart down here. I'm going to zoom in. I've given you 4 different terms down on the left-hand side. Terms can consist of more than one variable. They're the product of those variables, so we can multiply as many things together as we want. And so let's identify what all these pieces are so that we can decide what's a like term in a second. So they've labeled the coefficients in green, which is helpful. So when I look at 8c squared, 8 is the coefficient, right? Number in front. The variable is c, and the exponent is 2. So when I go to combine like terms, I can only combine them with other variables that are c and have a power of 2. They have to have both of those things going on. The next coefficient I see is 9 in this next term here. The variable is x, and if we don't see an exponent, we can assume it's a 1. The next one, there's no, with y to the power of 8, there's no coefficient written in front, so we can assume that's a 1. The variable is y, and the power is 8. So I can only combine that with other terms that have a y to the 8th power. And then lastly, 12, a to the second, b to the third. 12 is the coefficient. The variables are a and b, and each variable has to have that exact power. So you have to have a to the second power and b to the third power. Both of those need to show up in order to combine it with another like term. Okay. So this piece here says exactly what we wrote above. We need the same variable raised to the same exponent. Okay. And now let's try actually combining like terms. So all that means is that the part that is the variable with the power, that's never going to change. The coefficient is what changes. You're adding how many of those things you have, or subtracting. So our first example here says we have 3x plus 4x. If you notice, the variable is the same, and the power on that variable is the same, right? They both have a power of 1. So when I actually combine them, I'm adding the numbers in front, so 3 plus 4, which gives me 7x. So this would be my simplified expression, okay? In the second problem, 13xy minus 9xy, they have to have the same variables, both x and y, and both are raised to the first power. So as long as that's occurring, I can combine like terms, meaning I'm going to combine the coefficients. So 13 minus 9 gives us 4. If you see here, those variables do not change. Variables and powers don't change. All right, so if you look at the one directly below it, 11x squared minus 7x, this has the same variable, but the power here is a 2, the power here is a 1. So we cannot combine these because they are not like terms. They have to have the same variable raised to the same power. Okay. And then same over here, 4x plus 4y. Those two variables are different, so we cannot combine or cannot simplify. All right, let's do one more example together. So this is 7x plus 5 minus 3x. So we want to look for the variable. I see an x here and an x here. They both have a power of 1. So that tells me that I can put those two things together. So I want to think about, what is 7x minus 3x? Well, 7 minus 3 would give me 4x. And I still have this plus 5. Does that have anything that looks like a like term? Are there any other constants we could combine it with? No. So I'm just going to bring it down as part of my expression. So it's almost as if I rearranged those terms. This is a property of real numbers we'll talk about very soon. But I regrouped those numbers so that I could combine my like terms first, and then I just brought down the constant if there were no like terms to combine with it. All right. Thanks for taking some notes with me. We'll practice this next time in class.